Hello! Today I'm going to show you how to do partial fraction decomposition. So what does that mean? It means taking a complicated fraction that looks like this and writing it as a sum of simpler fractions, where the denominators of these simpler fractions are the factors of the denominator of this one here. So we'll write that out and we'll pick some variables for the top. We'll say a is going to be over 2x plus 1 plus b over x plus 1 plus c over x plus 3. So we can see like all the denominators here, all the factors on this side. First step then is we're going to rewrite this right hand side as one fraction. So basically put it into the same form as this, where the denominator is the same as this as the one on the left hand side. So to get a in the same form like that, to get this first fraction in the same form, we need to multiply top and bottom by x plus 1 and x plus 3. So it's going to be a lots of x plus 1, x plus 3. For b, we'll multiply top and bottom by the other factors, so 2x plus 1 and x plus 3. And for c, likewise, multiply it by 2x plus 1 and x plus 1. This thing then is going to be equal to the numerator on the left-hand side, 4 minus 2x. We could write the denominators on both sides, where it's just going to be the same thing as written over here. But now we know the denominators are the same, we can just compare the numerators and find the answer using those. So this is still very complicated on the right hand side. It's not something that we like to deal with. So we want to basically plug in a value for x so that some of the terms go to 0. And we'll choose a value such that we're only left with one a, b or c in each time. So looking at this first bracket, if we plug in x is equal to minus 1, this will become 0. It will also become 0 over here. So these two terms will be 0 and we'll be left with only this middle term in the centre. So we'll do that. And I think on the left hand side, minus 1 times minus 2 is positive 2, plus the 4 makes it 6 in total. And on the right hand side, well, that was 0 and that's 0. So let's just plug it into this b term over here. Minus 1 times 2 is minus 2, plus 1 is minus 1, and then 3 minus 1 is 2, so that's going to be minus 2. Lots of b. So we can see that b is going to be equal to minus 3 if we divide both sides by negative 2. Doing a similar thing then for this bracket, x plus 3. If we plug in x is equal to minus 3, on the left hand side, well, minus 3 times minus 2 gives us 6, add on the 4 gives us 10. On the right hand side then, well, that's going to be 0, that's going to be 0, so we're left with only this c term over here. And plugging in the minus 3, 2 times minus 3 is minus 6, plus 1 gives us minus 5, and then 1 minus 3 gives us minus 2, and then minus 5 times minus 2 is going to give us positive 10. So 10 is equal to 10c, so we can see straight away that c is equal to 1. Finally then, the next bracket, don't just do them in order, make sure that we've cancelled out each term. So like here we were left with just b, here we were left with just c, now we want to be left with just a, so we need to make sure we don't choose one of these brackets, we need to choose the other bracket. So doing that then, it's going to have to be minus 1 to make this, minus 1 over 2 to make this bracket equal to 0. So x is equal to minus 1 over 2. The left hand side then, well, minus a half times minus 2 is going to be positive 1, plus the 4 gives us a 5. On the right hand side, the only thing we should have left is the a term, because that's going to be 0, and that will be 0. So doing that then, and when you've got a complicated one like this, you don't have to do the summation in your head, like this multiplication in your head. We can think, well, 1 minus a half is going to be a half. 3 minus a half is 5 over 2. That's 5 over 2. Lots of a, like that. And now we can think, well, this 5 will divide with this 5. And we need to think now, what have we got? Well, the left-hand side will be 1 equal to a over 4. So therefore, we know that a is going to be equal to 4. Beautiful. Final step then is we need to rewrite this actually, involving our new constants that we found for a, b, and c. So we'll do that. Our original fraction, we call that f to save writing it out. F is equal to 4 over 2x plus 1 plus b, lots of x plus 1, but b is minus 3, so it's going to be minus 3 over x plus 1, and for c then was just 1, so it's 1 over x plus 3. Beautiful. Very important to note that this will only work when the order of the numerator is lower than the order of the denominator, and by that we mean that like the order is the highest power that appears in the polynomial. And on the top you can see here we've got x to the 1, so the order is 1. On the bottom, there's 3 x's here, so when they multiply together, you'd get x cubed, so the order there is 3. 1 is less than 3, so this should work fine. There's a different method for if it's equal, and another one if it's got repeated factors on the bottom. So as well, there needs to be no repeated factors on the bottom of this. But I'll do a video showing that as well.